Hi Navin. Hi Navin. Can you hear me? Can you hear me, Navin? Hello. Okay, Navin. Okay. Then we can start. Okay. What are we going to do? We are going to discuss some numericals. We are going to discuss some numericals from reflection. We are going to discuss some numericals from reflection. We have completed the theory of reflection, idea of reflection. We have studied the image formation by concave mirror and convex mirror, and also about the sign conventions. Then mirror formula, we have all that. Okay, that is, we have all the tools to solve our problems. To solve our problems about the convex mirror or concave mirror. How can we do that? Let's see what is the first question. Let's see what is the first question. Page number 12. Page number 12. Page number 12. Let's see what is the first question. As you all have that printed printed booklet with you, I will not be dictating the question. I will not be giving you the question. You have that question with you. So I will give you the question number. Then we will go to the answer. We will try to answer. Okay? Just one minute. So what is the first question? Everyone, please read the first question. What is it? What is the first question? The laws of reflection hold true for. That's an MCQ question. First question is an MCQ question. Laws of reflection. Laws of reflection hold for which type of mirrors? What is laws of reflection? What is laws of reflection? There was two laws of reflection. First one was I is equal to R, and the second one, everything lies on the same plane. Every terms lie on the same plane. That two were the laws of reflection. It holds for what type of mirrors? That is the question. What type of mirrors? Is it good for plane mirrors? Is it good for plane mirrors? Yeah, it's good for plane mirrors. It holds for plane mirrors. Okay. And what about concave mirror? Yeah, there is laws of reflection in concave mirrors, and convex mirrors also there. And all reflecting surfaces, that is the correct one. All reflecting surfaces, that is the correct one. Let's see how is this. What if we are checking A? A is okay, but don't give the answer as A. Just check the other answers. There will be more than correct answers. Then there will be one single answer. Right? There are more than correct answers, more than one correct answer. That means there should be one best answer. That best answer is what? All reflecting surfaces. Right? To every reflecting surfaces, laws of reflection is good. Okay. And what about the second one? Do you need anything to write from that? Just mark this. Just mark the answer. That will be all. I think. Okay. Navin, Jonathan, Neil, just mark that answer. What is the first answer of that question? All reflecting surfaces will be the answer. And the second question, that's for 1 mark, a VSA question. Okay. What is that? What is the magnification of the image formed by plane mirror and why? That is the second question. What is the magnification? Magnification of plane mirror. Of plane mirror. Right, guys? Right? Magnification of plane mirror. Magnification of plane mirror. We haven't discussed about magnification of plane mirror. Did we? No. Magnification of plane mirror. What can you say about the image formed by plane mirror? Yeah, same size. Image formed by the plane mirror will be of same size as that of the object. Then what is magnification? Magnification M. Two equations are there. One equation is HI divided by HO is one equation. HI by HO is one equation for magnification. Okay, that means HI by HO, right? What will be HI and HO in the case of plane mirror? They will be equal. They will be equal, right? They will be equal, right? Then what will happen? HI and HO will be cancelled from this. HI and HO will be cancelled from this, right? Will be cancelled from this. Then what will happen? If they are getting cancelled with each other, then what will be the final? That is M magnification will be 5 by 5. What is 5 by 5? 5 by 5 will be 1, right? You can cancel it and the answer will be 1. That means magnification is 1. Magnification is 1 for plane mirror. Is that okay? You can just study it by heart, but try to make it more easily. It will be more easy if you understand it correctly. How can you understand that? HA and HO are the image height and object height. That will be equal in the case of plane mirror. So HA by HO will be 1. Right? 5 by 5 is 1. Like that, HA by HO will be 1. So magnification is 1 for plane mirror. Right? Wherever be the object, magnification of plane mirror will be 1. Okay? And what about the next question? All these questions are actually previous year questions. Previously asked questions. So if you are practicing it very, very thoroughly, you will be very good at the coming exam. Okay? What is the next question? Spherical mirrors. The question is from spherical mirrors. The third one. What is the third one? An optical device forms an erect image of an object placed in front of it. What does the question say? What does the question say? An optical device. We don't know which optical device. We don't know which optical device. Try to answer with me. We don't know which optical device. Do we? No. Some optical device forms an erect image of an object placed in front of it. What is the image? What is the image? Erect. It forms an erect image. Erect image. That is the data given. If the size of the image is 1/2 that of the object, size of the image or height of the image. Height of the image is 1/2 that of the object. Okay? The optical device is what? What is that? Size of image. Size of image is HI. Size of image is HI and size of object is HO. We know that. In that question, it is saying that size of the image is half of that of the object. Size of the image is half of that of the object, right? And if object is HO, then HO divided by 2 will be H. This is what we are getting from the question. Half of the object size. Image size will be half of the object size, right? Right, Aaron? Right? Image size will be half of the object size. Then what can you say about the image? So, no, what can you say about the optical device? Which optical device that can? That is the question, right? And what can you understand from this idea that there is an optical device and it makes an erect image. Which type of optical devices can make erect image? Concave mirror, convex mirror also always produces erect images. Virtual images. We know that. What about concave mirror? It can also produce an erect image. It can also produce a virtual image. So you cannot write convex blindly. You cannot write convex blindly. Yeah. There is a case in concave where you get an erect image. So you cannot write convex at first. Just check it. And the height of the image, height will be more. What is HO divided by 2 means? Half of HO is HA. Who is bigger? Which is bigger, HA or HO? Which is bigger? Is HA bigger? Is HA is the bigger value? HO is the bigger value because if you are getting HA, what you have to do, you have to divide HO by 2. That means only half of HO is HA. So HO is bigger. That means height of the object is bigger than height of the image. Right? Height of the object is bigger than height of the image. I will just write height of object. Height of object. Height of object bigger than height of image. Height of object is bigger than height of image. Right? Or size of object is bigger and the size of the image is smaller. Size of the image is smaller. Then what type of mirror is this? What type of mirror is this? In the case of concave mirror, we are getting larger image. Just imagine that figure. Imagine that figure where we get an erect image for a concave mirror. Right? That erect image was bigger. That erect image was bigger than the object. So in this case, what is the only possible choice for this question? That will be convex because image is lesser in size. That means it is a convex. Can you understand? Can you understand the part of the answer? Then that will be convex mirror. Image size is lesser. Right? I will just write it like this. Image size is lesser. Image size is lesser. Image size is lesser. It is a virtual image. Erect means it is a virtual image. So this device produces a virtual image, and the size is lesser. Then that optical device will be convex. Convex mirror. It will be a convex mirror. It will be a convex mirror. Right? We have 2 points to answer this. What is the first point? The image is erect. It means image is virtual. If the image is erect, it means it is virtual. That's the first idea. And what is the second idea? We have from the question that HA will be half of HO, half of object distance. That means HO is greater and HA is smaller. Image size is lesser. When the image is lesser size than object, in the case of convex, only, then the optical device is what? Then the optical device, there is only one possibility. Then the optical device is what? That is convex mirror. What is it, Neil? Are you saying something, Neil? Okay. And what about this question? Is it okay? Okay. That's the third question, right? And the fourth one. What is the fourth one? Okay. What is the fourth one? Can we move to the fourth question? Just read the fourth question. The image or an object placed in front of a concave mirror of focal length of 15 centimeter is of the same size as the object. What happens there? Which type of mirror is there? There is a concave mirror and an object is placed in front of it. Focal length is given. Its focal length is given. If it is concave mirror, its focal length will be in front of the mirror, right? What is the focal length of a concave mirror? It is given in the question, that is 15 centimeter, but you will write 15 directly. Plus 15 or minus 15? It should be minus 15 because every measurement has to be taken from pole. That's the first one. And you are taking that measurement from right to left in the opposite direction of light. Okay? Opposite direction of light. That means It will be negative. So f will be minus 15 centimeters. Okay, from the question. And image of or an object placed in front of a concave mirror of focal length 15 centimeters is of the same size as the object. When are we getting the same size of object for the image? Not about the line. Not about the line. I am asking. You can put image. You can put object anywhere in front of the mirror, and you are getting same size of image. You are getting a same size image. Now, where are you putting your object? The only possible answer is C. When you are placing an object at C, where do you get an image? The image will be getting at the C itself. The image will be getting at the C, and the size of the image will be same as that of the object. Size of the image will be same as that of the object. Okay? So we have that idea. And what is the question? What is the question? The distance between the object and its image is what? Object and image. Distance between the object and its image is what? That is the question. Right? What is focal length? Capital, not capital. You have to give focal length small f. Focal length is small f. Right? So then focal length is the distance from pole to the principal axis. That is given as 15 centimeters. That is given as 15 centimeters. Is that okay? We have another idea that radius of curvature. Radius of curvature. What is the radius of curvature? Radius of the sphere. Whose part is our spherical? That is the radius of. Okay. And the radius of curvature is r. Then what is the relation between radius of curvature and the focal length? Now that means x is half of radius of curvature. You know, f is half of radius of curvature. Then what is radius of curvature? R is equal to 2 into f. R is equal to 2 into f. Is that okay? 2 into f. R is equal to 2 into f. What is R? 2 into, who is f? Minus 50. Then what is R? Minus 30. Minus 30 centimeter is R. What is R again? What is the definition of R? It is the radius of the sphere of which the mirror is a part. That means it is the distance from the center to the pole. Right? It is the distance from the center to the pole. Is that it? Then what is the position of center of curvature? Center of curvature will be at 30 centimeters in front of the. Did you get it? Did you get it? Center of curvature will be 30 centimeters in front of the mirror. Right? Because here you can see a 15 centimeter, another 50 centimeter you will get to see. That is radius of curvature. Now can you say that? Focal length will be half of radius of curvature. That means radius of curvature will be twice focal length. Twice of focal length. Then 2 into minus 15 will give you half radius of curvature. That means object is at C. Object is at C. And what are they asking for us to understand? The distance between object and its image. That's the question. No need to find this radius of curvature. I drifted a lot. There is no need to find radius of curvature. You understand that? But if you have an idea, you should write this one. But this point is not needed for this exam. This question. This point is not needed for this particular question. Okay? It is not needed for the particular question. Okay? what is our question? What is our question? What is the distance between object and image? We can see that both the object and image is in the same point. Both the object and the image is in the same point. Then what is the distance between object and image? There is no distance, right? Distance between object, distance between object and image. What is the distance between object and image? There is no distance between object and image. This is object, HO, height of object. This is image, HI, right? There is no distance between object and image. They are on the same point. That means distance between object and image is 0. That's the answer. Is that an option? Is there an option? Yeah. Then that's 0. 0 is our answer. Okay, good, Neil. Okay. Good. And what about the fifth one? Fifth one. The relation R is equal to 2F is valid. R is equal to 2F is valid. Can I move to the next page? Have you taken this note? Aaron? You should take this note. This is not needed, right? No need to find R, but you can find R by this method. That's why I show you this. Okay? Then I will use this space. I will use this space. What is the next question? Fifth question. Fifth question. We will only do 5 questions here. 5 questions from this part, and we will move to the next part. Okay? Fifth question. The relation R is equal to 2F. Fifth question. The relation R is equal to 2F. What is R is equal to 2F? Radius of curvature will be twice of focal length. That is the meaning. Valid concave mirrors, but not for convex mirrors. Convex mirrors, not for concave mirrors. There are 4 options. Which type of mirrors we can use this relation? In which type of mirrors we can use this relation? What about the plane mirror? Plane mirror does not have a radius of curvature, right? It does not have a radius of curvature. Radius of curvature is only for concave mirror and convex. It is only for concave mirror and convex mirror. Both of the cases it is okay. Both of the cases you can say R will be twice of focal length, but not in the case of lenses. There will be options of lenses for convex mirrors, but not for concave mirrors. Neither for concave mirrors, non-convex mirrors. No mention of lenses, right? In the options, there is no mention of lenses. But not convex, but not concave, neither concave nor convex. Then what will be the answer? It can be applied to both convex. It can be applied to both convex and concave. Both convex and concave can be applied to both convex and concave. Can be applied to both convex and concave. Both convex and concave. That's our answer. Both convex and concave. That's our answer. Okay, and we are stopping that at that point. And I am going to the next part. Page number 14. Page number 14. I am going to the next part. Page number 14. Please take page number 14. Page number 14. Yeah. No, I thought you can go on this way. Why did it happen? Do you have okay. But do you take medication? Which one? Spray. Okay. We are going to discuss 14th page. There is some question essay 2. The session essay 2, 3 marks question. 3 marks question. We are going to discuss 3 mark questions from there. 3 mark questions. Okay. The 13th question. Did you get it? 13th question. 13th question. What is the 13th question? Just read the 13th question and write on your notebooks. We are discussing 13th question. Jonathan, Navin, Neil, we are going to discuss 13th question. Please write question number 30 in your notebook. Okay. What is the 13th question? The magnification produced when an object is placed at a distance of 20 centimeter from a spherical mirror is plus 1 by 2 or half. Okay. So the magnification is given in the question and it is plus 1 by 2. It is plus 1 by 2. The magnification is given in the question and it is plus 1 by 2. Okay. And which type of mirror is that? A spherical mirror. They have not mentioned which type of mirror is that. Okay. So I am just writing it for my information. Spherical mirror. It's a spherical mirror. They have not said if it is a concave mirror or a convex mirror. Where should the object be placed to reduce the magnification to plus 1 by 2? Where should we place the object? That means, what do you have to find? Object distance. Where do you put the object means? What is the object distance? That is the question. In order to get magnification of plus 1 by 2. That's the question. In order to get the magnification of plus 1 by 3. That is the question. Okay. And is there any data? Is there any other data? There is the magnification produced when an object is placed at a distance of 20 centimeter from a spherical mirror is plus 1 by 2. That means the U is given here. U is given in the first case. What is U? U is 20 centimeter, but object is always placed in front of mirror. That means it always will be minus. Okay, so U will be minus 20 centimeter. You get it? Yeah. Okay. And what about here? Now you have to place the object somewhere else. You have to place the object somewhere else. I am just calling it U dash to make it more understandable. Okay, U dash. If you are placing the object at somewhere, that is U dash, you are getting a magnification and calling it M dash. And calling it M dash. You are getting a magnification of plus 1 by 3. Actually, I will repeat the question. We are going to discuss about the third question. What is that third question? Third question. The magnification produced when 30th question. When an object is placed at a distance of 20 centimeter from a spherical mirror. There is a spherical mirror. They have not mentioned which type of mirror is that. And from the spherical mirror, they are taking a 20 centimeter, that is the object distance, and placing an object here, and they are taking a magnification of plus 1 by 2. That is the first case. After that, they are asking for us to find where you should put the object, in order to get a magnification of plus 1 by 2. You have to get a magnification of plus 1 by 3. So, where are you going to place that object? That is the question. How can you find that? That is the idea. Just look at the figure. Just look at the figure. What is the given data? There is magnification and U. What is the equation connecting them? What is the equation connecting them?
Minus B by U.
Yeah, magnification is equal to minus B by U is the equation. From this equation, M is given and U is given. You can find the value of B. If you have B, just using mirror formula, you can find the formula. If you have formula, you can find and you are having another one that is 1 by 3. Is magnification. Okay? If you are having the value of focal length. How can you do that? What can you do with that? There is focal length, and you will find the magnification will be what? Let's see, what can we do from here? The magnification is 1 by 2 here, right? Plus 1 by 2. That will be minus b by okay, minus b by u. So minus v by u is magnification, and u, what is value of u? What is value of u? Minus v. We have minus v and minus u. Minus u. You have to take u as negative. You have to take u as negative. Instead of u, you can just write minus 20. You can just write minus 20. Then v by 20 is the answer. And v by 20 is 1 by 2. V is what? V will be, just take this 20 here. 20 divided by 2 will be the value of v, that is 10 centimeters. Right? 10 centimeters. V will be 10 centimeters. That means image is formed on the right side of the object. Sorry, right side of the mirror. That's why the distance v is a positive. Okay? And
Sir,
ah.
sir, I can't see what you wrote down.
Okay. I will move that part from here. I will move that part to here. Can you see now?
It's a little bit, I can see that side of.
So then again, I will stick to this part then. I will stick to this part. Okay?
Okay, sir.
Okay. What about now?
It's okay, sir.
Okay. And just read the question again. The magnification produced when an object is placed at a distance 20 centimeters from a spherical mirror is 1 by 2. Where should the object be placed to reduce the magnification to 1 by 3? That is the question. Okay. Now you have this B. B is what? Plus 10 centimeters. Plus 10 centimeters. Okay. And I'm going to take the second case. This is the first case, case 1. And we are going to take the case 2, second case. There is magnification which is given as m dash is equal to 1 by 3. M dash is equal to 1 by 3. M dash will be what? Minus v by u. M dash will be minus v. Okay? That will be minus v. This must be a little complicated. What is the focal length from here? Focal length from here. You have v and you have u. You can find the focal length of this mirror. From the equation of focal length, 1 by f is equal to 1 by v. You can find a simple formula for this. Okay? That may be somewhat complicated. 1 by f is equal to 1 by v plus 1 by u, right? Then 1 by v is 1 by 10. 1 by 10. And 1 by u is what? 1 by u minus 3. Minus 3. That means there is minus 20 plus 10 divided by minus 20 into 10 will be 200. Okay? That means you cannot see, you are not seeing that, right? Okay? Okay? What is it
Okay,
then?
sir.
Minus 20 plus 10 will be minus 10 divided by minus 200. What is it? 0 is gone. Minus and minus will be plus 1 by 20. 1 by 20 is f. 1 by f. So f is what? F is what? F is 20. Just take 20 for f. Right? F is 20. So you have f now. You have f now. And magnification also is here. And you have to find this u, value of u dash. What will be the value of u dash? How can you find u dash? U dash from here. This is u dash and then v dash. How can you find u dash from here? Just take u dash here and minus v dash by 3 will be u dash. Minus v dash divided by 3 will be u dash, right? That may be some complicated method. There must be some simpler method to do that. If we are finding this u dash and going from here, that will be a little complicated. Don't try to do this way. I will give you some simpler method, right? I will give you some simpler method. That's going to be some lengthy method. That's only for 3 months. Don't try to study this one. I will give you another, right? Another formula and another method I will give you. Okay. Okay. Just look at the 31st question. 31st question. We will do this. We will do this in another time. Just mark it. Just mark that question. We will do it another time. Just mark that later. Later. 30th question. We will do it later. Okay. 31st. What is 31st question? Define the following terms in the context of a diverging mirror. Principal focus. What is principal focus? Diverging mirror. What is diverging mirror? Diverging mirror. Diverging mirror is convex. That is first question. Diverging mirror. Diverging mirror. Diverging mirror is convex. Diverging mirror is convex. Okay? It's convex. Okay? And you have to discuss its principal focus. Principal focus. Principal focus. You have an idea. You have an idea about the principal focus of convex mirror. Do you have an idea about the principal focus of convex mirror? What is the principal focus of convex mirror? This is the convex mirror, and you will have a point on the principal axis where the incident ray that is parallel to principal axis gets reflected and appears to diverge from that point. Reflected rays appears to diverge from that point, then that point is principal focus of convex mirror. You should write it and note down. You don't have to write the theory again. You know that. Okay. Note down in this class. Okay. You know principal focus. What is principal focus? Principal focus. The light rays coming, the incident ray coming parallel to principal axis will get reflected and appears to diverge from a point on the principal axis. That point will be principal. We have that idea, so we can define it. And what is focal length? What is focal length in the case of convex lens? What is focal length? It is the distance from the pole to the principal focus. It is the distance from the pole to the principal of principal focus of a convex. That is focal length. That is the second one. Focal length. Are you good with it? Can you understand what is focal length? Okay. Then draw a labeled ray diagram to illustrate your answer. We have to give a labeled diagram, a ray diagram. This is the labeled ray diagram. What is this ray? This is incident ray. This is incident ray. And what is the ray? They are reflected. They are reflected. They are reflected. Okay, so that question is very, very simple one. Now the 32nd question, 32, question number 32. Just do the question number 32. Question number 32. Just read it. Read the question. A student has focused the image of an object of height. Just make it of object of height. Correct it. Object of height 3 centimeter. Object of height 3 centimeter. On a white screen using a concave mirror of focal length 12 centimeter. If the distance of the object from the mirror is 18 centimeter, find the value of the following. You have to find the distance of the image from the mirror and height of the image. How can you do that? How can you do that? The 30 second. Question number 30 second. What are the data given? The student has focused the image of an object of height. So you have given the height of the object. What is height of object? 3 centimeter. Can you understand from the question is that the height of the object is given? Can you understand from that question? Okay. On a white screen using a concave mirror. Which type of mirror are they using? A concave mirror. They are using a concave mirror. They are using a concave mirror. Then, for focal length 12 centimeter. What is the focal length of concave mirror? It is given as 12 centimeter. What about concave mirror? What nature of focal, principal focus will be in front of the mirror? Then focal length will be negative. Right? Focal length will be negative for concave mirror. You should have that idea. If the distance of the object from the mirror is 18 centimeter, if the object is placed here and the object distance, that is u. Object distance is 18 centimeter given in the question. What is the sign of 18? Positive or negative? Positive or negative? We are talking about the distance of the object. Will be negative. Distance of the object, right? Is the distance from the pole to the object. Okay, then that is given as 18 centimeters. That means it is measured in left first. So it is measured in the direction opposite to the direction of light. That will be negative. So u is also given. Find the value of the following. First one, distance of the image from the mirror. Distance of the image from the mirror. How can you do that? How can you find it? What is the distance of the image from the mirror? That is B. B is what? B is image distance. B is image distance. You have to find B. How can you find B? Just use the mirror formula. Just use mirror formula. You will get all the data is given. What is mirror formula? 1 by f is equal to 1 by v plus 1 by u. This is the mirror formula. Okay. And 1 by, what is f? F is minus 12 is equal to 1 by v. What is v? That's what we have to find. Plus 1 by, what is u? Minus 18. Right? This can be written like this: 1 by v minus 1 by 8. This minus can be taken out, and that will be 1 by v minus 1 by 8. Okay, that is 1 by minus 12. And if you want 1 by v, what you can do, just take this minus 1 by 18 to the other side. That means there will already be a minus a 1 by minus 12, and you are taking it to the right side, then that will be plus. So plus 1 by 18 goes to the other side. You are not seeing it. Okay. Okay. And what will be the answer? Just cross multiply it. That will be 18 plus 1 into minus 12 will be minus 12 divided by minus 12 into 18 is equal to 18 minus 12. 18 minus 12. What is that? 18 minus 12 will be 6. 6 divided by minus 12 into 18. You can cancel 6 and 18 with 6. 6 by 6 is 1 and 18. In 18 there is 3 6. Right? That means 1 by minus 12 into 3. What is minus 12 into 3? Minus 36. It will be minus 36. That means 1 by v is 1 by minus 36. Then v is what? Just take the value. This is equal. Reciprocal. You are taking the reciprocal, you will get v here, and the other side will be minus. Okay. So the value is minus 36 centimeter. You have the value of B as minus 36 centimeter. Is that all? No, you have to find height of the image. You have to find the height of the image. Height of the object is given. Height of the object is given. And you have to find the height of the image. How can you do that? How can you do that? You have to find the height of the image. Let's see. How can you do that? If the height is asked somewhere in the question, then there should be magnification. There should be magnification, equation of magnification. What is the equation of magnification? M is equal to Hi by Ho. M is equal to Hi by Ho. What about this question? Everyone in online, did you understand this question? How to do this question? The first part? Jonathan, Navin, Neil. Okay. And I am going
Yes,
to
sir.
the next part of the question. What is the next part of the question? That is second part. What is the second part of the question? You have to find height of the image. What is Hi? That is okay. You have this equation Hi by Ho with you, but magnification is also equal to, it is also equal to minus V by U. It is also equal to minus V by U, right? And you have V here and U also here, and Ho is given in the question. You can easily find the value of Hi. Okay, that will be value of Hi. How can you find the value of Hi? Just look here. Just look here. You have Hi by Ho. What is Ho from the question? That will be 3 centimeter is equal to minus V. What is the value of V? Minus 36. You don't have to think too much. Just put the values in or substitute the values in this equation. That's it. You will get an answer. Okay. Don't get confused with the should I put minus? Should I put plus? Should I put both? There is no case of that. Just substitute the values to the equation. You will get an answer. Okay. That means minus V. What is V? V is minus 36. So you should write minus 36 divided by U. What is U? U is given in the question. That is minus 18. Minus into minus will be plus. That will be 36 by minus 18. What is 36 by minus 18? 36 by minus 18? 1 and 2. Right?
-2.
Right? 36 divided by 18. That means minus 1. Minus 2. Minus 2 will be Hi by 3. Hi by 3 will be minus 2. Right? Yeah. Then Hi will be
-6.
minus
-6.
2 into 3. What is minus 2 into 3? Minus 6 centimeter. From this, you can see, you can understand that what will be the nature of image. Image will be inverted, right? Image will be inverted. And magnification, value of magnification is what? Magnification is not directly given. But value of magnification will be what? Will be a negative value. Value of magnification will be a negative value. Who has a negative value for magnification? Real image. So this image will be real and it is inverted. What about the size of the image? Size of the image as compared to size of the object. Now it is actually, it is of course, it is obviously bigger. What is the height of the object? That is 3 centimeter, and the height of the image is 6 centimeter. Height of the image is 6 centimeter. That is, image is larger. Image is larger than the object. Okay. Okay, Jonathan, Navin, Neil. Is the question okay?
Yes, sir.
Should I repeat it?
Yes,
Should I
sir.
repeat the question?
No, sir.
Okay. What about you all? Aaron, everything okay? Is the question okay? Sarah? Okay, let's see another question. Let's see another question. 33. Just mark the questions we have already discussed it. Mark the questions we have already discussed in this class. that is from 1 to 5. We have discussed from 1 to 5. So you have to put a tick mark on 1 to 5. Question numbers 1 to 5. We have already discussed the question numbers 1 to 5. Question numbers 1 to 5. In page 14, we are setting aside the 13th question. We are setting aside the 13th question. We are not going to discuss it right now. We will find a better one, a simpler one. So the 13th question is not a big question. We haven't done it, but 31st question. The question number 31, we have done it. Tick mark, put a tick mark on 31, question number 31, and question number 32. What about question number 33? What about question number 33? What does that question say? What does it ask? Draw a ray diagram for the following case when a ray of light passing through center of curvature of a concave mirror is incident on it. Right? A ray of light is incident on concave mirror. The path or to which point passing through center of curvature. What happens to that light ray? Aaron, what happens to that light ray? When light ray is passing through center of curvature, what happens to that light ray? It gets reflected in the same path. You can draw it. Okay, that is not going to be a problem. You can draw it, right? Second one, parallel to principal axis is incident on convex mirror. What happens to a light ray that is coming parallel to principal axis and hitting on convex mirror? What happens to it? It gets reflected. It gets reflected. And what will happen to it? Question number 33. It will get reflected, and if this is convex mirror, a light ray coming parallel to principal axis will appears to diverge, gets reflected and appears to diverge from a point. That point is principal focus, right? So you are asked to draw this figure. You can draw this figure, right? Should you draw this one? And should you write the question or mark the question number and draw this figure? Do you need that? Do you need to redraw it again? Huh? It will be okay, I think, right? And third one is passing through focus of a concave mirror. What will happen to a light ray which is passing through principal focus? That is the question, right? Principal focus. A light ray is passing through principal focus and it is hitting on concave mirror. What will happen? It gets reflected and it will return parallel to. It goes parallel to principal axis. It goes parallel to principal axis. Do you need to write this one or draw this one? So just try to roughly do that. Just try to roughly do that by using 33. Roughly do that. Don't use scale or pencil. Don't use scale or pencil. Just put 33, question number 33, and try to draw these figures. This is the second figure, right? This is the second figure, and this is the third figure. And what was the first figure? Passing through center of curvature. What will happen to light ray then? What is the mirror? The concave mirror. And that is a concave mirror, and this is principal axis, this is center of curvature. Center of curvature is here, and they are asking to find, asking to draw the light ray that is passing through center of curvature. If light ray is passing through center of curvature, it will get reflected and will return to the same path. It will return to the same path. These are the figures. Very simple figure. Just draw the rough figures. Just draw the rough figures. Don't use compass, pencil, or scale, anything like that. Just the raw, just the rough figures. Rough figures only is needed. Okay. We have some more time. So we will look at 34. Question number 34. We will be discussing question number 34 also. That's another numerical question. Just read the question 34. Just read the question 34. What is the question 34? A concave mirror is used for image formation for. There is some data missing there. That's actually a typing error. Typing error. Just put that data in that question. I will give you that. A concave mirror is used for image formation for. Just give an arrow there and write for different positions of an object. For different positions of an object. We are discussing question number 34, and there is some data you should add to the question. I am giving you that data. Okay, a concave mirror is used for image formation for. Put an arrow and write above it different positions of an object. Different positions of an object. Different positions of an object. What inferences can be drawn about the rest is same. The rest of the question is same. What inferences can be drawn about the following when an object is placed at a distance of 10 centimeters, right? I will try to do this question. Just look here. This is the 34. Question number 34. They are asking about a concave mirror. They are asking about a concave mirror. We have to do about a concave mirror, image formation, and the object is placed at a distance of 10 centimeters. Just roughly draw a concave figure. An object is placed 10 centimeters in front of the mirror, right? Then you will be having a value minus 10 centimeter, right? You will be having a value minus 10 centimeter, okay? For the pole of from the pole of a concave mirror of focal length of 15 centimeter. Concave mirror focal length is given. What is the focal length? Given in the question 15 centimeter. 15 centimeter. Is it positive value or negative value? Should be negative. Must be negative because you have to measure from pole to principal focus. For pole to principal focus, that will be negative value. It is against the direction of light. It is against the direction of light, right? So principal focal length will be minus 15. What do you have to find? You have to find position of the image at first. What is the position of the image? What is the position? Which quantity will give you the position of the image? V. If you are finding V, you will get position. V is image distance, right? Then find V and you have the position. Okay? And position, for position, you have to find V. That's how you have to understand that. That's how you are understanding that. You have to find V, position, V. Okay? And use mirror formula. What is mirror formula? 1 by x is equal to 1 by v plus 1 by u. Just find u from here. That will be all 1 by f. F is minus 1 by minus 15. 1 by v. You have to find 1 by v and plus 1 by u. What is 1 by u? 1 by u. 1 by minus 10. 1 by minus 10. Okay? And it can be written as what? Can be written as, I will add one more step. Minus 1 by 10. It will be minus 1 by 10. Right? Just take this minus 1 by 10 to the other side of the equation. What will happen? You have a 1 by minus 15 there, and you are just taking this minus 1 by 10, and it will be plus 1 by 10. Plus 1 by 10, you will get 1 by 8. You are not seeing it, right? Okay? Okay? And how can you do that? Just cross multiply it. 10 into 1 will be 10 plus 1 into minus 15 will be minus 15 divided by minus 15 into 10. Cross multiply it. Okay? That will be 1 by 3. And 10 minus 15. What is 10 minus 15? 10 minus 15, 5. put a minus, right? Divided by minus 15 into 10. Just you can cancel it with the 5, you will get a 1 here, you will get a 2 here, and minus divided by minus will be plus. Minus by minus will be plus, that is 1 by b. It means 1 by 15 into 2. 30. 1 by 30 will be 1 by b. Then b will be 30 centimeter will be the value of c. 30 centimeter will be the value of c. That is the first question. We have seen the position of the image. And what is the size of the image? What is the size of the image? How can you find the size of the image? Can I move to a little bit here? Okay. What is the size of the image? That is the second one. B, size of the image. How can you find the size? Magnification. Okay. Magnification M is equal to HI by HO. But there is no mention of HI or HO. Is there? No. So minus B by U will be the equation. What is minus B? What is minus B? Minus B is 30 divided by what is U? What is U? What is the value of U? Minus 10. U is minus 10, right? U is minus 10. So you have to put U as minus 10. Then minus divided by minus will be positive. 30 by 3 will be 3. That means magnification is what? 3. Magnification is what? 3. And is there any mention of height of the image? Any mention of height of image? No. If there is any mention of height of image, height of object, you can see that height of image will be 3 times height of object. What is this? What is the meaning of this? If magnification is 3, what is the meaning of it? Image is 3 times larger than object. That is the meaning of magnification. Right? Image is 3 times larger than object. You can write it like that. Image is 3 times larger. Image is 3 times larger than object. Image is 3 times larger than object. Okay? Image is 3 times larger than object. That's all. That's the question B. And what about C? C, nature of the image. How you will find the nature of the image? From the magnification. From magnification, you can find the nature of image. Right? What does the sign of this magnification? What is the sign of this magnification? It is positive. If magnification is positive, the image will be virtual. Image will be virtual. If it is virtual, it will be erect. Virtual and erect. The image will be virtual and erect. We can understand from magnification. It will be virtual and erect. That's the nature of the image. And size of the image. Size of the image. What will be the size of the image? 3 times more enlarged. Enlarged. Size will be enlarged. That is 3 times. 3 times. 3 times larger than the object. It will be 3 times larger than the object. It will be 3 times larger than the object. Okay? Yeah? I will start a little bit of theory. A little bit of theory. That is refraction. Refraction. We are going to discuss refraction. Can I erase the board? Okay. I will use this side. And I'm going to discuss refraction with you. Refraction. This is the second property of light we are going to discuss in this chapter. Second property. That is refraction. What is refraction? Let's see. Just erasing it. What is refraction? You have You have a glass slab like this. You have a glass slab like this. Or I will give you very simple. Okay, simple. There is light, and this is air. Consider this as air, and this is water. Right? That's air and water. Light ray is traveling from air to water in an angle. Light ray is traveling from air to water in an angle, right? At this point of incidence, you can draw what? You can draw normal. At this point of incidence, you can draw a normal. What is normal? A line perpendicular to the surface. That is normal. And what will be the direction of the incident ray? The direction of incident ray must be this. The direction of incident ray must be this. Right? The incident ray has to go through this path. But there is a medium change. There is a medium change. The medium is changing. Right? Medium is changing air to water. Air to water. That is, thickness of air and water will be different. Thickness of or density of air and water will be different. Or optical density of air and water will be different. Because of that difference, there will be a bending of light. There will be a bending of light happening. The light will bend, right? The light will bend like this. The light will bend like this. The light will bend like this. Right? This is a refraction. We can see many practical applications of refraction in daily life. Have you ever observed an aquarium? If you are just looking at an aquarium, you can see the bottom part of the aquarium on the top of water. You can see it. You can see it. You can see the bottom part of aquarium on the top, or you can see the bottom of a clear pond. When you are just observing a pond from a distance, you can see the bottom part of the pond is elevated a little. Elevated a little. You may mistakenly think that the depth is very low. It is having very low depth, and by imagining the depth is very low, and you are just diving it by thinking the depth is very low, that will be dangerous. The actual depth will be more than that. Actual depth will be more than that, but you can see that there one. You can see the bottom of the pond a little bit elevated. That is because of the refraction. And another simple one. You are just taking a beaker of water, a glass of water, like this, and you are just putting a pen or a pencil into it. What will happen? Just you are putting a pen or pencil here, and you will feel like it is broken. You will feel like it is broken. Is the pen or pencil actually broken? No, it is not. But you may think it is broken. That's because refraction. That's because bending of light. Where do we see an object? Where do we see an object? Or there is another thing. There is archery. Archery fishing is the archery. By archery, or by using boards, you can catch fish. If you are just aiming at a fish in the pond, where you have to aim a little further. Then only you can catch that fish. You can hit that fish. If you are just aiming at the fish, where you are seeing that fish, you will not get it. You will not hitting that fish. If you want to hit that fish, you have to hit a little bit above it, some distance from it. That means the actual position of the fish will be a little bit further. Why is that? That's because of refraction. The light coming from the fish to our eye will be bent. Where do we see an object? Where do we see an object? Where does the light comes from? Where does the light comes from? That is the position we are seeing an object. I can just throw something. I can just throw this thing on arrow. I can just throw this thing on arrow, and it may hit arrow. It may hit arrow. Why is that? I can aim him like this, and I can throw this thing at him. I can do that, right? Because light is hitting on arrow, and light is reaching from that point to my eyes. That way, I can point or I can aim at arrow. Because there is no medium difference. There is no difference of medium. But what if a medium is different between us? There is a medium, there is another medium between us, like water or glass. Then I will not be seeing arrow at exactly the right position because of the bending of light. Light from arrow will be coming from a little bit further, a little bit to this side, and it is reaching my eyes, and I may think arrow is there. Arrow is there, and I am just aiming at the arrow and trying to throw this thing on arrow. It will not hit on. It will not strike on thing. Why is that? Because the light rays is not actually coming from arrow. It is coming from another point. It is coming from another point. But I can see an image where the light rays is coming. I can see the image where the light rays is coming. I will see an image where the light rays is coming. Okay, that's refraction. There are many other practical applications for refraction. You will be studying about that in the higher classes. Okay, and so this is refraction, and that's the idea of refraction. And another thing you have to study that laws of refraction. Laws of refraction. What may be the laws of refraction? The first law will be like the law of reflection. The first law is exactly same for reflection and refraction. First law is exactly similar for reflection and refraction. What is the first law? The incident ray normal to the surface or normal at the point of incidence, and reflected ray all lie on the same plane. That is the first law for reflection. The exact same law is for refraction. So all lie on the same plane. All lie on the same plane. That is the first law. And the second, for the second law, I will introduce you to two angles. The first angle is the angle between incident ray. What is this one? What is this one? This is incident ray, and this one, this is normal, and this is I. What is I? Of incidence, right? I is angle of incidence. So I is angle of incidence. You know that angle of incidence. Then what is I? I is the angle between incident ray and normal. What is I? Angle between incident ray and normal. That is I. And there is a reflected ray. Sorry, refracted ray. What is this ray? This is a refracted ray. This is refracted ray. And what is this? This line? This line, it is normal. It is normal. That means there will be another angle, that is angle of refraction. Angle of refraction. What is R? Angle of refraction. Angle of refraction. Refraction angle. That will be between normal and a refracted ray. So what is angle of refraction? Is the angle between the refracted ray and normal. That is okay. And what about sine I? Sine I. There is an identity called sine, and another one called cos. There is also another one tan. Have you studied about the sine, cos, tan? Right? No. Then I will give you that idea. I will give you that idea, right? What type of triangle is this? That is right angle, right? That means the angle here will be 90. Okay. And I am just taking this angle here, that is theta. Theta is a symbol which we are using for angle. So you can see there is a theta. Okay. And this side is x. This side is x. You are just taking this side as x and this side is y. Right? This is a right angle triangle. That means there is a 90-degree here. There will be a 90-degree here. And the side close to theta will be x and the side which is far away from theta is y. Is the figure okay? Then there will be some ideas you can find from here. You can apply here. What is Pythagoras theorem? You know. You are already aware of Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square. This is hypotenuse. Let this be said. Hypotenuse square will be x square plus y square. Will be a base square and plus the vertical square. You know that is Pythagoras. Like that, there is something called the trigonometry. There is something called the trigonometry. Trigonometry is the mathematical ideas we are applying on a right angle triangle. Some mathematical ideas we are applying on a right angled triangle. Right angled triangle. The one mathematical idea is that you can find a property of this angle. That property is sin theta. That sin theta will be a value opposite side by hypotenuse. What is opposite side here? Y. What is hypotenuse here? Z. That is side. Right? And what is another property also is that is cos theta. Cos theta will be adjacent side by hypotenuse. Who is adjacent side to theta? X will be adjacent side to theta. Then x divided by hypotenuse. Who is hypotenuse here? That's Z. Hypotenuse, the larger, the lengthier one. That is hypotenuse. So that is sin theta and cos. That is sin theta and cos theta. That is sin theta and cos theta. Okay. Okay. It is sin theta and cos theta. It is about sin theta and cos theta. You understand that? You understand that idea? Okay. Then only I can give you an idea about the next one. Okay. I will give you the next law, the second law. The second law is that you can find the sine line, right? There must be a sine line if you are taking this line as perpendicular to the normal, and you will get a sine angle. You can find the value of sine. And sine I, you are just taking another value, that is sine r. How will you get sine r? You are just drawing a perpendicular here, that is 90 degree here, and then there will be a sine r also. Then there will be a sine r also. You are just taking sine r also, and you are dividing them. You are dividing sine r with the sine I. That is sine I by sine r. Sine I by sine r will be a constant. There's a name. This law is called Snell's law. You don't have to write it in the 10th standard. The law is called Snell's law. Snell's law. Sin I by sin r will be a constant. That is Snell's law. That is Snell's law. Sin I by sin r will be a constant. How can you define it? How can you make it into a law? How can you make it into words? The ratio of, how can you convert this line into word? the ratio of this line. The line into word is the ratio of, right? Is the ratio. The ratio between some number on the above and other number on below. So a ratio of angle, sine of angle of incidence. How can you convert sine I into words? Can you convert sine I into words? Sine of angle of incidence. Sine of angle of incidence. That is sine. So ratio of sine of angle of incidence to be
Sir,
uh,
sir, can you go a little bit down?
okay. Sorry. This is Snell's law. This is Snell's law. Okay. And again, how can you convert it into words? The ratio of sine of angle of incidence to be sine of angle of refraction will be a constant. That's the second law of refraction. How is it? That's the second law of refraction. Ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant, which will be a constant. And that constant has a name. That constant has a name, and that constant is actually something else. I will just write it, and I will teach you what is that constant, what does it mean in the next class. Right? This constant is constant has actually a value. Or if you are just finding sine I by sine R, you will get a value. That value is n to 1. What is that value? N to 1. That's relative refractive index. That may be new term to you. Just study it and you will be hearing that very fast from now on. What is n to 1? N to 1 is a constant. This is the constant, and that constant is actually having a value that is n to 1, represented by n to 1. What is n to 1? It's relative refractive index. It is relative refractive index. So you can call it as refractive index of second medium with respect to first medium. How can we call it? Refractive index of second medium with respect to first medium. And it is having an equation that will be n2 by n1. What is n2 and n1? I will teach you in another class. I will tell you in another class. You just have to understand n21 can be written as n2 by n1. That's it. That's easy, right? n21, n2 by n1. This n2 and this n1, that's 400 plus. Okay? And this is the case of refraction. Can we write it? Can we write the case of refraction? Just write it. Just write it. Give a subheading. The second property, just give a second. Just give a number 2. Just give a number 2, Roman letter 2 if you like. A Roman letter 2 if you like. We are going to discuss about your refraction. Right? Refraction. Right? Refraction. And draw this figure. This figure is the figure which is showing refraction. This figure is showing refraction. So let's draw that refraction. Just draw that figure. The figure is showing refraction. Okay. Draw the figure. This is the surface of separation. Right? The line is the boundary. This line, you can see that this line, you're just seeing from here, and there is air, and there is water below. There you can see a boundary. That is surface of separation or boundary. Boundary between two medium. What is medium? Medium, the space in which The space through which the light travels. The space through which the light travels. If it is traveling through air, air is a medium. If it is traveling through vacuum is not a medium. Vacuum is vacuum. And vacuum is not called medium. If light is traveling through glass, glass is the medium. If light is traveling through water, then water is the medium. If it is passing through diamond, is the medium is diamond. Does the light pass through stone? Light can light pass through concrete? No. The concrete cannot be a medium of light. Got the idea? Okay, just draw the figure. Draw the figure. Draw the figure. Figure already. Okay, just define the refraction. Just write. The bending of light ray, the bending of light ray, when it travels from the bending of the light ray, when it travels from one medium, to another. One medium to another medium. That is the shortest definition. There may be some larger definition, but this is enough. What is that definition? The bending of the light when it travels from one medium to another. Got it? That is a refraction. And just name these two terms. What are those two terms? I is what? Angle of incidence. R, angle of refraction. I is angle of incidence, and R is angle of refraction. What is I? Do you need to write what is I? No need of it. Right? I is angle of incidence is what? Angle between incidence ray and normal. Don't have to write. Right? Okay. What is the angle of refraction? It is the angle between refracting ray and normal. So you just write I, that is angle of incidence, R, that is angle of refraction. Got it? Then write the laws of refraction. That's the second point, second subheading, laws of refraction. Don't get confused, be confused with the reflection, right? Laws of refraction. Okay, the first one. Write the first law. Incident ray, refracted ray, and normal to the surface, at the point of incidence, all lie on the same plane. That is the first one. Okay? Write the second one. Second one is Snell's law. Snell is the name of someone. So you should put capital S. For Snell's law. Snell's law. What is Snell's law? That is the second law. Second law has a name, Snell's law. Right? Snell's law. What is Snell's law? Just write the ratio of sine of angle of incidence. When you are writing sine, it will be like this. When you are writing sine, it will be like this. When you are giving it a symbol, or when you are using it in mathematical form, it will be sine theta or sine 90. You can write it like this. If you are writing it, that should be in this side. The ratio of sine of angle of incidence to the Sine of angle of incidence to be sine of angle of incidence to be sine of angle of refraction. Sine of angle of refraction is constant. Is constant. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant.
Sir, can you repeat again?
Should I repeat?
Yes, sir.
Okay. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant. Did you write up to that point? Is a constant.
Yes, sir.
Is a constant for a given color and a given pair of medium. For a given color. For a given color. For a given color and given pair of medium. For a given color and a given pair of medium. Given color and a given pair of medium. Given color and a given pair of medium. What does that mean? What does that mean? Right? What does that mean? This value, that is sin A by sin R, will be different for different. If you are using blue light, you will get a value for sin A by sin R. If you are using red light, you will get another value for sin A by sin R. If you are using yellow light, you will get another value for sin A by sin R. That's it. And what is this case? Medium. If you are finding the sin A by sin R of air, water, it will be a value. And if you are finding the sin A by sin R for air, glass, it will be another value. If you are finding the sin A by sin R for water and glass, it will be another value. That is the way. But you may not have to write this when you are asked to write that. If you are asked to write the laws of refraction, just write like this: ratio of sine of angle of incidence to the sine of angle of refraction is a constant. That's all. That's all. That will be enough. But that is for actually for a given color and a given media, given pair of media. It's a condition. You may not have to write a condition. Okay, that's all. That is our class today, and we will discuss the rest in the next class. Okay, I will try to set an extra session. Most of the days I have other classes that I am not getting any time to give an extra session to you. I will try to organize an extra session for you for this 10 years, and we will discuss more numericals. We can discuss the numericals in the extra session. We will take the class in the regular session, and we will discuss the numericals in the next class. Okay. Okay. Take care. By all, I will give you some homework from this print, from the print booklet, and you have to do it and bring them in the next one. Okay, not many questions, some three or four questions. Only some 3 or 4 questions. Just try to practice it and bring in the next class, and we will discuss again that in the class, in the same class again. Okay. See you. Happy, very happy for that, and happy birthday to them. Can I ask how old are you? 15. Okay. We won't just to get the legal age for license and the legal age for to shoot a vote and to decide who is ruling, who is going to rule. Okay. Happy. Okay. I am actually on fasting. I will have this after the fasting. Okay.
You need a.
No, that's it. I will write it. You just write it. I will pick it.
Thank you, sir.
Okay. Thank you, Naveen. Thank you, Jonathan. Just put an arrow here. 34 question, right? 4. Just to give an arrow. This. 4, just given a